Hey everyone! Surprised you're back. Honestly, it got a little awkward during that antibiotics unit. Well, I apologize. Welcome to the first video in our unit on antifungal drugs. Let's start with amphotericin. You know what? Amphotericin gets a pretty bad rap, doesn't it? I've heard 'em all. Amphoterrible, Amphotower of Terror, Amphoterigillium. I mean, how terrible could it really be? When I think of amphotericin, you know what comes to mind? Amphibians, of course. Our recurring sketchy symbol for this toxic drug. Our scene takes place in a community college science classroom where some lab amphibians are making a daring escape. Let's see if amphotericin is really as terrible as everyone says. First of all, see the terrarium? Every science classroom has one. At least the cool ones do. And we're going to sketch some fungus in it to remind you that we are talking antifungals here. Ergosterol is found in the cell membrane of fungi, while the dominant sterol of human and bacterial cells is cholesterol. So, the glass of our fungal terrarium will represent the fungal cell membrane. This is where amphotericin acts. We'll sketch in this sign on the wall above the terrarium, non-sterol, not only to remind kids to wash their hands after handling amphibians, but that the fungal cell membrane is not your usual sterol. It's comprised of ergosterol instead of cholesterol. Amphotericin binds to ergosterol and forms pores in the cell membrane, allowing leakage of electrolytes and macromolecules and eventually cell death. We'll convey this mechanism of action here at the wall of the terrarium, where amphibians are making their escape. These frogs of Nim are breaking through holes in the glass, just like pores in an ergosterol membrane, and also notice water is leaking through these holes just like leakage of electrolytes. If an exam question mentions resistance to amphotericin, it will involve changing the molecular components of the fungal cell membrane. If a fungal pathogen decreases the amount of ergosterol in its membrane, amphotericin can't insert pores to kill the cell. Amphotericin B is the antifungal with the broadest spectrum of action. It has activity against pretty much any serious fungal infection you throw at it. This includes yeasts like Candida and Cryptococcus, endemic mycoses like Histo, Blasto, Coccidio, and molds like Aspergillosis and Mucor. Think of amphotericin as your antifungal used in severe systemic or life-threatening fungal infections. This will be represented by the anatomical model, a biology classroom fixture, next to the amphotericin terrarium. All these organs exposed should remind you of infections such as severe fungal pneumonia, severe cryptococcal meningitis, just look at that brain, or disseminated infection with one of the endemic mycoses such as Histo or Coccidio. Amphotericin is given IV in order to treat systemic infections, and to highlight IV administration, notice the IV at the top of the terrarium. Notice too, that frog inside is doing that big neck croak thing that frogs do. This is to evoke the image of a round liposome. Because of amphotericin's severe toxicities, liposomal drug formulations have been developed. This permits packaging of the drug in lipid delivery vehicles, which decreases drug binding to human cholesterol membranes, thus lowering toxicity. This chubby frog isn't going to wreak any havoc today. Let's talk about those toxicities, because there are a lot of them, and they can be separated into two categories: infusion-related immediate reactions and slow cumulative toxicity. First of all, these toxicities result from amphotericin non-selectively binding to mammalian cholesterol membranes instead of ergosterol membranes. So, one of our frogs is clinging onto a teacher's necktie, which is decorated with the structure of mammalian cholesterol. Infusion-related reactions are nearly universal and consist of fever, chills, muscle spasms, vomiting, headache, and hypotension. The headache and hypotension will be represented by the teacher who is grabbing his head and fainting as an immediate reaction to the frog suddenly jumping onto his tie. He's knocked over a Bunsen burner, and this red, sweaty frog who is shaking in fear next to the flame depicts the classic shake and bake fever and chills. Amphotericin is still sometimes used to treat fungal CNS infections and must be administered intrathecally. We'll sketch in a frog here who is latched onto the model brain with his tongue, kind of like an intrathecal line. This kind of administration can cause major CNS side effects, including seizures and neurological damage. Notice, we've added our sketchy seizure action lines to this frog in order to convey this. Also, during systemic administration, thrombophlebitis can occur at the injection site, and this will be highlighted by the blue veiny pattern on the frogs in the scene. Next, let's highlight the more cumulative toxicities. Renal damage is the most significant toxic reaction. In fact, renal impairment occurs in nearly all patients. Amphotericin can lead to reversible prerenal azotemia or irreversible renal tubular injury, leading to a type 1 renal tubular acidosis. We usually convey a tubular acidosis with a test tube of acid, and in this classroom we have a budding chemist holding a graduated cylinder full of acid. Notice the graduated cylinder is shaped like the number 1 in order to emphasize a type 1 renal tubular acidosis. RTA type 1 is associated with hypokalemia, so that's why he's sipping on this potassium-depleted banana peel. Amphotericin toxicity also leads to renal magnesium wasting, represented by the magnesium magnet he was using to stir the kidney beaker contents falling into the sink. Volume expansion with IV normal saline is usually initiated before drug administration in order to ameliorate the initial decline in GFR and prevent ensuing renal damage. To represent this, we have emergency saline shower next to our chemist, who is embodying all that is nephrotoxic about amphotericin. Now would probably be a good time to use it. All this damage to renal tubular cells leads to anemia because the kidney can no longer produce adequate amounts of EPO. Take a look at the kidney-shaped beaker that is knocked over and shattered. Its red contents are now draining down the sink, while a frightened pale frog hops to safety. Let this remind you of decreased EPO production by the kidney, leading to anemia. See that falling rack of test tubes? I just want to emphasize that damage to renal tubular cells can cause anemia because the kidney is an important organ of EPO production. Remember that anemia does not have to originate in the bone marrow. Amphotericin B is one of the primary drugs used to treat cryptococcal meningitis, and it is often used in combination with the antifungal agent flucytosine to rapidly sterilize the CSF. Flucytosine will be highlighted in the music classroom across the hall, where a student is practicing flute. Take a look at the sheet music in front of our flucytosine flute player, which will convey this mechanism of action. As one of the escaped frogs hops across the music stand, keep an eye on the notes we've highlighted. We have F and C next to each other, representing how flucytosine starts like a fluorinated cytosine. Then, as the frog hops off the page, the C has tipped over and turned into a U, depicting how cytosine deaminase converts flucytosine into 5-fluorouracil. From here, it's converted into a few more forms before being incorporated into growing strands of DNA and RNA and halting their synthesis. The bars of music drawn on the chalkboard spiral into DNA and RNA strands, and a frog has smeared them, depicting this halt in DNA and RNA synthesis. A question on an exam might word this mechanism as fungal DNA replication and fungal protein synthesis being inhibited. To emphasize that the flucytosine and amphotericin combo is often used for Cryptococcus specifically, we'll sketch in the name of the opera for which our fungal flutist is practicing, Anthony and Cleopatra, with Cleopatra's crypt sketch on the chalkboard as well, which resembles our Cryptococcus sketchy micro sketch. One more drug to cover in this sketch, and that's nystatin. Nystatin has the same mechanism of action as amphotericin. In other words, it binds ergosterol in fungal cell membranes, creating pores and causing cell lysis. So it will be depicted right outside the amphibian-ridden lab room in the hallway. Notice the Be Nice sign to emphasize the name nystatin. Nystatin is active against most Candida species, as symbolized by our Canada Canadian flag, with numerous patches of snow outside, just like the easily scraped patches of Candida. Nystatin is available for topical use to treat mucocutaneous candidiasis, including vaginal candidiasis, as depicted by the student outside getting pelted in the crotch. Typical Canadian antics. Underneath our beautiful Canadian view, we have a drinking fountain, reminding you of the old swish and swallow. Nystatin is used as a rinse for oropharyngeal candidiasis. Esophageal candidiasis, however, must be treated systemically. Check out our fluconazole sketch for more details. All right, let's sum up this sketch. Both nystatin and amphotericin work by binding the fungal cell membrane, creating cell pores, and causing cell lysis. The non-sterile sign should remind you that the fungal cell membrane contains ergosterol, not cholesterol. Amphotericin is used for serious systemic fungal infections and causes immediate reactions, such as the shake and bake fevers, and more cumulative toxicities such as renal-induced magnesium and potassium wasting, anemia, and renal tubular acidosis. Nystatin, on the other hand, is used topically to treat candida infections, either as the old swish and swallow for oropharyngeal candidiasis or topically for mucocutaneous candidiasis. Over in our flucytosine music classroom, notice that flucytosine starts out like a fluorinated cytosine before being converted into 5-FU. It inhibits fungal DNA and RNA synthesis and is used in combination with amphotericin to treat cryptococcal meningitis. Okay. Remember, your essays are due tomorrow. That's right, 2,000 words on flucytosine theory and appreciation. And for the love of ergosterol, if one more student turns in an assignment in Comic Sans, he is going to feel my wrath. Insubordinate.